Question 1. The table shows the menu at a cafe. So here we've got the menu. Part A. Lucy buys a cereal bar, a coffee, a salad and a piece of fruit. Write down the prices for these items in order of cost. Okay, so we're ordering them and we're starting with the cheapest. So, cereal bar, 86 pence. Coffee, £1.85. A salad, £4.23. And a piece of fruit is 60 pence. So we've got 86 pence, £1.85, £4.23 and 60 pence. So we're going to put them in order of cost, starting with the cheapest. So the cheapest will be the smallest price. So the smallest price is 60 pence. So the fruit is the cheapest. Then 86 pence is a cereal bar. And then £1.85 is cheaper than £4.23, so it would be coffee. And then salad, so 60p, 86p, £1.85 and £4.23. Part B. The cafe offers a meal deal. Buy any main item with a drink and a snack for £5. So we get a main, a drink and a snack for £5. Jason buys a sandwich. Later he buys a tea and a packet of crisps. How much less would he have paid? So how much less would he have paid if he had bought these 3 items using the meal deal? Okay, so if he bought any main item, so he bought a sandwich, so he had £3.49. Then later he went and got a drink. So he got a tea at £1.20. And then a snack, his packet of crisps at £1. So buying them the way he did, we're going to add those up. £3.49, add £1.20, add £1. Cost him £5.69. How much less would he have paid? Well, he would have only paid £5. So £5.69 subtract £5. He would have paid £0.69 less, or 69 pence. Part C. On Monday, Emma buys 8 soft drinks. What is the total cost for this? So soft drinks are 95 pence. So 95 pence times 8 is 760 pence. You can leave it as pence, or if you divide it by 100, because there are 100 pence in a pound, that is also £7.60. On Tuesday, Emma only buys coffees. She spends £12.95. So only coffee, and she spends £12.95. How many coffees does she buy? So we're going to do £12.95 divided by the price of a coffee. So if we go back to our table, coffee is £1.85. So we're going to do £12.95 divided by £1.85. Which is 7. So she bought 7 coffees. Question 2. Part A. Complete the pattern below so that AB is a line of symmetry. Shape the smallest possible number of squares. So if AB is a line of symmetry, then both sides of the line should match. So this square here, we should also have an equivalent square here. These 2 squares match. We need to have this square here. We want it to match on the other side. So we've got this square shaded here, so we're going to have to shade this one. These 2 match, but these 2 need to match. These 2 match, and these 2 match. So now that line AB is the line of symmetry. Part B. Circle the shape below that has rotational symmetry of order 4. Okay, so rotational symmetry of order 4 means it fits into itself 4 times exactly. So this is going to be the shape that has order of rotational symmetry 4. because each of these semicircles with this smaller shaded part match in these 4 places. The others, they have differences, so they wouldn't have an order of symmetry of 4 when we rotate it. Part C. The diagram below shows a triangular prism. How many edges and vertices does the triangular prism have? So edges are these straight lines. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. And then the vertices are the corners. 1, 2, 3, 4, 5, 6. Part D. Draw one line to connect each of the following mathematical names to the correct shape. You will not need to use every shape. One has been completed for you. So they've already matched the rectangle. We need to match the rhombus, trapezium, kite and hexagon. So this is a kite. A hexagon has 6 sides, so it's going to be this one. A trapezium is this shape here. And then the next one is a rhombus, which is this shape here. So a rhombus is different to a parallelogram. So a rhombus has all 4 sides the same, where a parallelogram has different widths compared to lengths. Question 3a. Peter uses numbers and a symbol to correctly write 1/7 is greater than 1/8. So we've got 1/7 being greater than 1/8. Circle what Peter writes. So this symbol greater than is that symbol there. So it can't be this one. Wrong symbol. Wrong symbol because it's got a line underneath which is greater than or equal to. Wrong symbol. This is the right symbol. So 1/7 is greater than 1/8. So it's going to be this one. Part B. A large jar contains 8,571 jelly beans. 2,857 of the jelly beans in the jar are blue. Use one of the 5 options shown below to complete the sentence. So we've got fractions here. 1/5, 1/4, 1/3, 1/2 or 2/3. So a fraction of the jelly beans in the jar are blue. So we have 2,857 blue out of 8,571. So I'm going to pop that into my calculator as a fraction. 2857 over 8571. And it simplifies to 1/3, which is here. So I'm going to repeat those words here. 1/3. Part C. 3 of the factors of 18 have a sum of 17. Write these 3 factors in the boxes below. So let's start. We want the factors of 18 to start off with. So 1 and 18, I'm listing factor pairs. 2 and 9, 3 and 6 are our factors of 18. And it tells us that 3 of them have a sum of 17. So 3 of them will add up to 17. Anything we add to 18 is going to go above 17, so we're not going to include 18 in this. Okay, so we've got here 9 and 6. Well, 9 plus 6 is 15. To make 17, we need to add the 2. And then when we add the 2, we get 17. So I'm going to use 2, 6, and 9. Question 4. Reese owns a bakery. He recorded how many cupcakes he sold each day. The results for the first 4 days are displayed in the pictogram below. So here's our pictogram, and the key tells us that this shape split into 4 equal parts represents 12 cupcakes. So we need to be aware of that. That's important. Part A. Reese sold 42 cupcakes on Friday. Complete the pictogram for Friday. So each whole shape is 12 cupcakes, and each whole shape is split into 4. 12 divided by 4 is 3. So each of these little shapes, the triangles, are 3 cupcakes. So Reese sold 42 on Friday. So 12, 24, 36, 48. So we're going to have 3 hole shapes. But then we're going from 36 to 42, which is 6. So we want another 6. Each of these is worth 3. So we're just going to take half of that shape. Part A, part 2. How many cupcakes did Reese sell in total from Monday to Friday? Well, we know that Friday was 42. Thursday, 12. 12 and then 6. So 12 plus 12 plus 6. So that's 30. 1, 2, 3, 4 lots of 12. 48. So then we've got 12, 3, 6, 9. So 12 plus 9. And then 1, 2, 3 lots of 12 is 36. And then we're going to add all of those together. So we're going to do 36 plus 21 plus 48 plus 30 plus 42. Which is 177. So 177 sold in total. On Saturday, Reese sold 17 cupcakes. Explain why the key used for the pictogram is not suitable to show this. So the key, 4 of those equal parts is 12. So if we do 17 take away 12, that leaves us with 5. The other parts of the shape are equal to 3. So 5 isn't divisible by 3. So we'd say, let's say the remainder 5 is not divisible by 3. So we wouldn't be able to split that shape up to represent it appropriately. 5A, the diagram below shows a number machine. So we've got the input and then we multiply by 6. We add 2.3 and then that gives us our output. When the input is 8, what is the output? So we're starting with 8, then we're multiplying it by 6, which gives us 48, then we're adding 2.3. So 48 plus 2.3 is 50.3 and that's our output. Part 2, when the output is 34.7, what is the input? So if we're starting with the output, we're going in the opposite direction, so we need to do the inverse operations. So we're starting with 34.7, but instead of adding 2.3, we're going to subtract 2.3, which gives us 32.4. And then instead of multiplying by 6, we're going to divide by 6, which is 5.4. Part B. The diagram shows some boxes and some balls on a balanced scale. All the boxes have the same mass. All the balls have the same mass. Calculate the mass of each box and the mass of each ball. Okay, so because these scales are balanced, these boxes must total 6.5. So we've got 1, 2, 3, 4, 5. So 5 boxes is 6.5 kilograms. So I can use that information to find one box. The opposite of multiplying by 5 is divide by 5. So 6.5 divided by 5 tells me that each box is 1.3 kilograms. Now let's equate this scale. So we've got one box plus 2 balls. Let's call the balls C. Bit weird, but we're going to do it. They equal 5.5. Now we know that a box is equal to 1.3, so we're going to replace the box with the 1.3. Now I'm going to subtract 1.3. And then we're going to divide by 2. So the mass of each box is 1.3 kilograms and the mass of each ball is 2.1 kilograms. Question 6. Philip has 250 coins in his money box. 22% are £1 coins. 2/5 are 20p coins. The rest are 10p coins. Part A, how many £1 coins are there in Philip's money box? So 22% of 250 is £1 coins. So I'm going to find 22% of 250 by multiplying by 0.22. 0.22 is the decimal equivalent of 22%, so I can use it as a multiplier in this instance. So times by 0.22 tells me that 55 of those coins are £1. So he has 55 £1 coins. Part B, how many 20p coins are there in Philip's money box? So we're looking at 20p coins now, and it tells us that there are 2/5. So we're looking for 2/5 of 250. Two ways you can do this. You can write the answer in the fraction in your calculator and times it by 250, or you could divide by 5 and multiply by 2. So there are 120p coins. What is the total value of the coins in Philip's money box? So total value here. So we've got 55 times £1, which is £55. We've got 100 times 20 pence, but I'm going to call that 0.2. So times 0.2 equals £20 in 20 pence. The rest of the coins are 10p coins. So we've got 55 and 100. So 55 plus 100, that's 155 of the coins. We've got 250 in total. So if I subtract what I know, that tells us that there are 95 10p coins. So we're going to do 95 times 0.10. So 95 times 0.1, which is £9.50. And then we're going to find that total. So £9.50, add 20, add 55 is a total of £84.50. Question 7. Reem has made a scale model of her car. The diagram below shows the plan view of her model. And it says here the scale is 1 centimetre represents half a metre. So what I'm going to do is half a metre is 50 centimetres. I know that, so I'm going to write that there in case it helps me later. Part A, find the length of Reem's actual car. So we're finding the length of her actual car. So we need to find the length of this diagram to start off with. So making sure your ruler's flush here on 0. So the length of the car is 8.6 centimetres. So 1 centimetre represents 50 centimetres in real life. So 1 gives us 50. So let's call that the drawing and real life. We've got 8.6. So if we times by 8.6, it should tell us the real length of the car. 8.6 times 50 is 430 centimetres. Or we could say that is also 4.3 metres, which is a more realistic measurement to use for a car, isn't it? Metres rather than centimetres. Part B. The height of Reem's actual car is 1.7 metres. Calculate the height of the model car. Give your answer in centimetres. Okay, so let's do another proportion table because I like to organise my information. So we've got the drawing and we've got real life. So on the drawing, 1 centimetre is 50 centimetres. In real life, her car is 1.7 metres, which is 170 centimetres. Okay, so I want to find out what it is here. So what I'm going to do is I'm going to divide 170 by 50. That tells me that we need to multiply by 3.4. So when I multiply by 3.4 here, 1 times 3.4, it's 3.4 centimetres on the diagram. Question 8. Shazad has 6 numbered cards, 17, 31, 13, 23, 15 and 21. Part A, what is the median of the numbers on Shazad's cards? So the median is the middle. So I need to put these numbers in order. I'm going to go from smallest to biggest, and then I need to find the middle number. So the smallest number is 13. Then it's 15. I'm crossing them off as I go so that I know I've used all the numbers and I don't get confused and use them more than once. So I'm just ordering them from smallest to biggest, and now I'm going to find the median. So I'm going to cross off from either side. So we have two numbers left in the middle. The median is the middle of those two numbers. So I'm going to add them together, which is 38. And then I'm going to divide by 2 to find the middle, which is 19. So the median is 19. Part B. Liz says, I can pick 5 of Shazad's cards that have a mean of 21. Which 5 cards must Liz pick for her statement to be correct? You must show all your working. So 5 of those cards, when we add them together and divide by 5, we get a mean of 21. Because when we find the mean, we add them all together and we divide by how many we have. So let's work out what they're going to total. So if we have a mean of 21, with 5 cards, 21 times 5 will give us the total that those cards add up to. So we're looking for 5 cards that add to 105. Okay, so let's start here. So 105 subtract 31, subtract 23. So that's that 31, 23. So we want to make 51. So that's not going to work. So 17 plus 23 is 40. Thirteen plus 15 is 28, so that would be 68. So one more to make 105, so that's 2, 32, 37, so that's not going to work. So 13 plus 15 plus 17 plus 21 plus 23. Okay. 15 plus 17 plus 21 plus 23 plus 31. That's too big. By 2, look. So 13 plus 17 plus 21 plus 23 plus 31. There we go. So we're going to have 13, 17, 21, 23 and 31. 13, 17, 21, 23 and 31. They total 105, and when we divide that by the 5 numbers we get that mean of 21. Question 9. The diagram below shows 3 identical squares. It's not drawn to scale, so we can't measure anything. Calculate the size of angle X. So we're looking for this angle here. So this information about 3 identical squares is important, and if we're dealing with angles and trying to find an angle, let's fill in as many angles as we can. So first things first, on a square, all of our angles are 90 degrees. So I'm just going to label any angles that join onto this shape directly. Okay. Now it said we've got 3 identical squares, which means all the sides of a square are the same, but it means also that all of these sides are the same. So here we've got a triangle with 3 equal sides, which is an equilateral triangle, which means that that must have an angle of 60. Now here we're dealing with angles around a point. So we've got 60 plus 90 plus 90 plus x, and that has to give us 360. So 60 plus 90 plus 90. So x plus 240 equals 360. So x must be equal to 360 subtract 240, which is 120 degrees. Question 10. The conversion graph below may be used to change between distances in miles and distances in kilometres. So we've got miles and kilometres on this graph. Use the graph to answer the following questions. Part A. Aaron and Jenny both went for a run. Aaron ran 28 kilometres. Jenny ran 15 miles. Who ran the longer distance? So to be able to compare them, we need to be in the same unit. So we're either going to convert this to miles or this to kilometres. So let's go with changing Aaron to miles. So Aaron's in kilometres, so we need to look up here for 28 kilometres. So 10, 20, 25, 26, 27, 28. And then what we're going to do, we're going to read across to the line on the graph. Oh. And then we're going to read down and read off that value in miles. So we've got 15 to 20, and it's halfway, so that's 17.5 miles. 17.5 is a longer distance than 15, so Aaron ran longer. Part B, complete the following statement. You must show all your working. 36 miles is equal to some kilometres. Now what you'll notice is this doesn't go up to 36. So what we need to do is find a value that we can then convert to 36. So I know 12 is a factor of 36. So I'm going to find out what 12 miles is as kilometres. So that would be 11, 12. So starting at miles, going up to the graph. Okay. So that's 19. So 12 miles is 19 kilometres. We want 36 miles. So we would have to times by 3. So 36 miles equals 57 kilometres. 11a, simplify the expression here. So first thing I'm going to do is I'm going to expand the bracket. This term here isn't included with the bracket, so I'm going to ignore it for now. 4 times x is 4x. 4 times positive 6 is positive 24. And then I've still got this plus 3x on the end. Now I'm going to collect like terms. So I've got 4x, add 3x. So I have 7x, add 24 in total. Part B, solve f divided by 3 equals 5.1. It's written as a fraction, so it's a division. So I'm going to multiply by 3. So f is 15.3. C, find the value of x when w equals 3 and y equals 24. So I'm going to substitute these two values here into that equation. So x equals w, which is 3, bracket y plus 2, 24 plus 2, all divided by 8. And then let's just stick that in our calculator. Is 9.75. Question 12a, calculate this sum, give your answer correct to 2 decimal places. So we're going to enter this into our calculator, but what's really important to note is the only values inside that square root are those values. The add 2.1 squared is separate. So I'm going to put the square root symbol in. 5 times 3.8, but then I'm going to arrow off and out of my square root before I do the add 2.1 squared. So I'm going to write down the whole thing to start off with. And then I'm going to round it to 2 decimal places. 1, 2, that 8 is going to change that 6, so it's 8.77. Part B. Write 0.05834 correct to one significant figure. So when we're dealing with small numbers that start with zeros, these zeros here are not significant. The 5 is the first significant figure, and then the 8 will change the 5 because it's 5 or above. So it becomes 0.06. It's important you keep those zeros. They're not significant in terms of the rounding aspect, but they are significant in terms of the place value of the number. Question 13. Ken measured the resting heart rate in beats per minute of 12 people. He asked them how many hours of exercise they usually completed each week. The results for 7 of the people have been plotted on the scatter diagram. So we've got this scatter diagram here. Resting heart rate and then hours of exercise per week. Part A. Here are the results for the remaining 5 people. Plot these results on the scatter diagram. So we're going to plot these results onto this graph. So hours of exercise per week was along the bottom. So I'm going 2 along and then 70 up. So 2 along up to 70. That's the first person. 4 along up to 58. So 4 and up to 55, 6, 7, 8. 1 along and then up to 60. 1 up to 60. 7 along up to 55. So 7, 50, 55. Make sure you pay careful attention to that scale. And then 5.5 along to 57. So we've got 5, 5.5 and then going up to 55, 6, 7. So 1, 2, 3, 4, 5. We've plotted those remaining 5 parts. Part B. Ken recorded one person's resting heart rate incorrectly. Circle the point on the scatter diagram that this is most likely to be. So if it's been recorded incorrectly, it's likely to be an outlier that's not following the trend of the data. So this point here is not following the trend of the rest of the data. It's too far away, so that would be our outlier here for part B. C. Describe the relationship between hours of exercise per week and resting heart rate of the people Ken asked. Ignore the result that was recorded incorrectly. So it wants us to describe. So we're not going to use any numbers here. We're just going to describe what we can see from the graph. Okay. So the higher the resting heart rate, the lower the hours of exercise, because that's the highest resting heart rate, but they've done the least amount of exercise. And then if we look across here, as the hours of exercise increases, the resting heart rate decreases. And that's what we'd expect sensibly, because the fitter we are, the more we exercise, the lower our resting heart rate is. So the higher the more hours of exercise per week, the lower the resting heart rate. So that's what I'm going to write here. The more hours of exercise per week, the higher, oh, that's not what I said. The lower the resting heart rate. You could also say the opposite. You could say the lower the heart rate, the less hours of exercise per week. 14A. Geomet High School has 740 students. Each student was asked which method of travel listed below was their main method of travel to school. The table below shows the methods of travel together with some of their probabilities. So we're working with probabilities here. So we've got method of travel, walk, bus, bike, car, train or other, and then the probabilities here. And what we have to remember is that the probabilities add to 1. So all of these here will total 1. Part 1, a student is chosen at random. What is the probability that this student walks to school or travels to school by bus? Okay, so the probability that they walk is 0.2 and the probability that they travel to school by bus is 0.35. So we're going to add those together, 0.2, 0.35, which is 0.55 as a probability. We're working in decimals, so we're going to stay in decimals for our answers. How many of the 740 students travel to school by bus? Okay, So there are 740 students in total, and the probability that they travelled by bus is 0.35. So if we do 740 times 0.35, that gives us 259 students that travel to school by bus. Part 3. The probability that a student travels to school by car is twice the probability that a student travels to school by train. Calculate the probability that a student travels to school by train. So this is looking at the blanks in that table up there. And if you remember, I made that note to myself that these probabilities must add up to 1. So the first thing I'm going to do is I'm going to add up the probabilities that I know. So 0.2 plus 0.35 plus 0.3 plus 0, but I'm not going to pop that into my sum because it makes no difference to the answer. So 0.85. This has all got to add to 1 because probabilities are between 0 and 1. So if I take that probability away, 0.15 needs to be split between car and train. Now it tells us here, travelling to school by car has twice the probability. So this is going to be 2 lots and this is going to be 1 lot of this 15. So I'm going to split this into 3. So 0.15 divided by 3 equals 0.05. So 2 lots of that would be travelling to school by car, and then 1 lot of that would be travelling to school by train, because this is 2 lots and this is 1 lot. So this is the probability that they travel to school by train. I'm just going to make that nice and clear. Part B. The Venn diagram shows information about the number of students who study music and drama in Year 11 at Geomet High School. So we've got this Venn diagram here, 2 overlapping circles. Music is this part of the Venn diagram, drama is this part. There are 104 students in Year 11. Complete the Venn diagram to show the number of students in Year 11 who do not study music or drama. So the do not study music or drama would fall on this line here outside the Venn diagram, not inside. So we know there are 104 students in total. These are the number of students that have already been taken into account. So we're going to subtract these from 104. So 104 subtract 17, 14 and 11. Which leaves us with 62. So 62 would be completed on the outside of the diagram. That those are the students in Year 11 who do not study music or drama. What is the probability that a student chosen at random from Year 11 studies music? Okay, so random from Year 11 means we're taking them out of the whole Year 11 cohort. There are 104 students in total in Year 11. So I'm going to pop 104 on the bottom of my fraction for my probability. So studying music. This is the circle for studying music. So the 17 and the 14 are all students that study music. Now this 17 only study music, this 14 study music and drama. However, it doesn't specify only music, it just says music in general. So we're going to include both of these on the numerator of our fraction. 17 plus 14 is 31 out of 104 is the probability that a student chosen at random from Year 11 studies music. Question 15. A shop sells storage boxes. A stack of 4 of these boxes is shown below. So we've got a stack of 4 boxes, and it gives us the height of 1 box and the height of all 4 boxes. The height of a single box is 35.2 centimetres, which they've labelled on the diagram for us. The height of 4 of the same boxes when stacked is 52 centimetres, which is also on the diagram for us here. A different stack of these boxes has a height of 85.6 centimetres. How many boxes are in this stack? So the important thing to notice here is that the boxes stack inside each other. So it's not simply a case of having one box on top of another. It's this lip here, look, that's on the top. So we need to figure out what the size of that lip is, okay? So we know from here to here is one full box, including its lip, that's 35.2 centimetres. So from here to here is 1, 2, 3 of those lips of the box. Now this whole height from the base of this first box all the way up to top is 52. So the difference between these two heights is equal to these 3 lips here. So I'm going to take the heights away from each other to start off with. So 16.8, so that is equal to 1, 2, 3 lips. So let's find out how much one lip of a box is. So I'm going to divide that by 3. So 5.6. So these are all still in centimetres. So each one of these is 5.6, okay? So we've got a different stack of these boxes with a height of 85.6 centimetres. Now we know that the height of the bottom box is going to be 35.2. It's the same boxes. So I'm going to start by taking 35.2 from the total height of this new stack. 50.4. So this 50.4 must be made up of lips of boxes because they fit into each other. So I need to see how many of these 5.6s fit into 50.4. Nine. So there are 9 lips in this new stack on top of that first box. So we have 9 plus 1, which tells us there are 10 boxes in that new stack. Question 16. Make G the subject of the formula. So we're going to rearrange this formula so that it says G equals instead of H equals. And we're going to do this using inverse operations. So the first thing I'm going to do is I'm going to move the K. So I don't want this K to be here. Now there's no sign in front of it, so it tells me it's positive K. The opposite of a positive K would be a negative K. So I'm going to start by subtracting K from both sides. So when I subtract K from the left-hand side, it's H subtract K. I simply write it because I don't know the value of H and K, so I can't calculate it. And then when I subtract K from this side, it eliminates K and leaves me with 2G. I'm aiming to get G on its own here. It doesn't matter which side the subject is on, so I'm okay with G being on the right hand side. The next thing I need to do is I want it to be equal to 1G. At the moment I've got 2G, 2 times G. The opposite of timesing by 2 would be to divide by 2. So when I divide by 2 it gives me G on the right hand side, but this is where you need to be careful. When you divide by 2 on the left-hand side, you need to divide everything by 2, so you need to write it as a fraction. And there you have it. You've written G as the subject of the formula. Question 17. Translate this triangle using the vector 3, -4. So we've got a triangle here drawn on this grid for us. We're going to translate it. Translate it means to simply move it. So we're going to move the triangle according to this vector, this column vector. So the top of the triangle tells us left or right, and the bottom of the triangle tells us up or down. Now this is +3, so we're going to go to the right 3 places. And then this is -4, so we're going to go down 4. So I'm going to pick a point on this triangle and I'm going to take that point right 3 places, 3 whole squares, corner to corner, 1, 2, 3, and then down 4, 1, 2, 3, 4. So it's going to move to here. I'm going to do the same with the next vertex of the triangle. So we're going to go right 3 places, 3 corners exactly, 1, 2, 3, and then down 4. 1, 2, 3, 4. And then with the last vertex of the shape, right 3, 1, 2, 3, down 4, 1, 2, 3, 4. I would recommend you doing this in pencil, because then if you do miscount and make a mistake, you can rub it out and start again. There we go. Part B. Rotate this shape 90 degrees clockwise about the point 0, 0. So let's find the point we're rotating around first. 0, 0 is the origin, which is that point there. So I'm going to get a piece of tracing paper. If you're in an exam and tracing paper isn't provided in an exam pack for you, you can ask for it. So if you want tracing paper at any point, pop your hand up and ask for a piece of tracing paper. So what I'm going to do here is I'm going to mark that centre, and then I'm going to trace the shape. Again, I would use pencil, guys, if I were you, just in case you make a mistake. And then I'm going to pop an arrow going upwards, because that's going to help me spot how many turns I have made with this shape. Now, it wants us to turn 90 degrees clockwise. So clockwise is this way, and 90 degrees is a quarter turn. So I'm going to turn this a quarter turn so it's made a right angle. So I'm going to make sure my tracing paper's still where it should be on my diagram. I'm going to put my pencil on here, and I'm going to rotate my shape until that arrow is gone 90 degrees or made a quarter turn. So then it shows me here where I need to draw my shape. So between 4 and 3 there. So like this. And then I've kept my shape as it was orientated, so I know how to draw it. There we go. Question 18. So it's telling us we're going to use the formula pressure equals force divided by area. And we've got a picture of a filing cabinet here. So it says the base of a filing cabinet is a rectangle. So the bottom of this cabinet is a rectangle that measures 45 by 60 centimetres. The whole of the base is in contact with the horizontal ground. So all of the bottom of the filing cabinet is in contact with the ground. Part A. The empty filing cabinet exerts a force of 675 newtons on the ground. What is the pressure exerted on the ground by the empty filing cabinet? Give your answer in n centimetres squared. The reason why we're dealing with n centimetres squared, or newtons per centimetre squared, is because our force is given in newtons and our area will be in centimetres squared once we've calculated it. So we're going to find the area that's in contact with the ground. So the area is this rectangle that measures 45 by 60 centimetres. So the area of the rectangle is 45 by 60 centimetres, which is 2,700 centimetres squared. Now it tells us our area is in centimetres squared here, so we don't need to convert it. And we also know we need it to stay as it is because of the units for the force, for the pressure, sorry, in that final example. So it tells us that pressure equals the force, which we know is 675, divided by the area, which we know is 2,700. So 675 divided by 2,700. So we've got a pressure of 0.25 newtons per centimetre squared. Make sure you write those units. It's given you the units there, look. And we know we're in newtons per centimetre squared because our area is in centimetres squared and our force is in newtons. Part B. When the filing cabinet is full, the pressure on the ground is 0.75 newtons per centimetre squared. What is the force that the full filing cabinet exerts on the ground? Give your answer in newtons. So the formula we have is pressure equals force over area. All right. We're wanting to work out the force now. We've been given the pressure as 0.75. So I've substituted that there for the P. We know the area is the same. It's 2,700 centimetres squared. but it's this force here that we're trying to work out. So the force would be equal to the pressure times the area. So the force is equal to 2,700 times by 0.75, which is 3,600 newtons. Remember, it asked for it in newtons, so that's what we're going to give it. Question 19. The diagram shows information about the percentage of households in Eduqas that owned a desktop computer for the even numbered years from 2006 to 2018. So we're dealing with the even numbered years. So we can see here 2006, 2008, 10, 12, 14, 16, 18, the even numbered years. Okay, so this is the diagram. Part A, complete this statement. The percentage of households that owned a desktop computer decreased the most between the even numbered years blank and blank. So we're looking for the highest decrease between 2 years. Okay, so if we look here, between 2006 and 2008 it's increasing. Between 2008 and 2010 it's increasing. And then we're carrying on increasing until we get to 2014. That's when it starts decreasing. It decreases between 2014 and 2016. Then it decreases again between 2016 and 2018. So which of these is the highest decrease? Well, we're looking for the steepest line. So it's going to be between 2014 and 2016 here, because it's gone from 89 to 75, whereas here we've gone from 75 to 72. So this is definitely the biggest decrease. So we're going from 2014 to 2016. Jane says the graph shows that 70% of people owned a desktop computer in 2009 because it passes through that point. So 70% of people owned a desktop computer in 2009 because it passes through that point. Okay. 2009. If we draw a line up. Okay. So, yeah, she's right. It passes through that point, but we don't know the exact value for 2009. So no, she's not correct, because this would just be an estimate. Okay, it would be an estimate. We can't say for certain because we don't have an exact point plotted. Part B. The table shows information about the percentage of households in Eduqas that had an internet connection for the even numbered years. So we're dealing with internet connections now. Got the information here. On the diagram on page 24, plot the information for an internet connection. So we're going to plot these. So the year goes along the bottom, and then the percentage for the internet connection is going to go up the top. So we're going from 2006 to 45, which is here. 2008 to 53. 50, 1, 2, 3. Make sure you know what the scale's going up in, guys. 2010 to 66. 65, 66. 2012 to 79. 79. 2014 to 84. 2014. 80, 1, 2, 3, 4. 2016 to 88. 80, 5, 6, 7, 8. And 2018 to 89. So 89. And then we're going to plot, we're going to draw, straight lines through those like they have in the previous graph. So we've got a line graph that we can use then for the rest of the question. Okay, so that's part 1 done. Part 2, in which even numbered year was the difference in percentage of households So the difference in the percentage of households in Edgevale owning a desktop computer and the percentage of households having an internet connection the greatest. So we're looking for the 2 points that are the furthest apart. So if you look at the graph here, so these are pretty equal. This is a bit further apart. So these are the points that are the furthest apart. So we need to figure out which it's going to be. So here we're at, that's 78, that's 66, that's 88, and that's 75. So 78 take away 66. Let's see what that difference is. It's a difference of 12. 88 take away 75. Oh, is a difference of 13. So this is the biggest difference. So it would be for 2016. Edgevale is a large town in a county. Comment on how in this county the percentage of households owning a desktop computer and the percentage of households having an internet connection are likely to have changed in this time period. So it's a large town in a county. Okay. So how would the percentage of households that have a desktop computer and internet connection have changed in this period? Well, you would expect that it's increased in this period because if it's a large town in a county, the population is going to increase, and obviously internet, etc., has gotten more prevalent in households over the years. So it's likely to have increased as desktops and internet become more available. Or any other comment you want to make about the use of technology. (20A). The diagram shows a circle inside a square of side 8.2 centimetres. So we've got a square with a circle inside, and the square's got a side of 8.2 centimetres. The sides of the square are tangents to the circle. Find the area of the shaded region. So we're wanting the area of these parts here. Okay? So when we're finding the area of a shaded region, we need to find the area of the whole shape, and then we need to take away the area of the shape that's not shaded. So we want the area of the square and we want the area of the circle. And then we're going to subtract them from each other. So because the square has a side of 8.2, the area of the square is 8.2 times 8.2, or 8.2 squared, which is 67.24 centimetres squared. To find the area of a circle, we do pi times radius squared. So we need to know the radius of this circle. This part here where it tells us that the sides of the square are tangents to the circle. This tells us that actually the side of the square is the same as the diameter of the circle. And we know that the diameter is twice the radius. So if the diameter equals 8.2, then the radius equals 8.2 divided by 2. Which is 4.1. So the area of the circle is pi times 4.1 squared. Which is 52.81017251. Don't clear your calculator at this point, so we don't have to enter all those digits back in again. So to find the shaded area, we're going to take the area of the circle away from the square. So 67.24 subtract 52.81, etc. So if I put 67.24 subtract and press my answer button, because I didn't clear it before, it's kept all of those digits in for me, which would be 14.429,82749. I've written out the whole thing, centimetres squared. It hasn't told me to round it in any way, but because it's given me things to one decimal place, I'm just going to neaten things up. So it'd be 14.4 centimetres squared, but this will get you full marks. Part B, the diagram shows a parallelogram. It is the cross section of a prism. So a prism is a 3D shape. So we would have lengths that carry on off this parallelogram. Find the length. Oh, the length of the prism is 16 centimeters. Find the volume of the prism. So we need the area of the cross section times by the length for the volume. So this is the cross section. So we're going to find the area of the parallelogram. So the area of a parallelogram is the base times the perpendicular height. So the base is 9.8. The perpendicular height is the 7, not this length here. That's a slanted side. The perpendicular height is at a right angle to the base. So we're going to multiply by 7 and then we're going to multiply it by the length which they've given us. So 9.8 times 7 times 16. Which is 1097.6. We're dealing with centimetres and volume, so it's centimetres cubed for the units. 21a, solve 7x subtract 5 equals 2x add 3. So we've got an equation where we've got the unknown on both sides. So the first thing I'm going to do is I'm going to eliminate the smallest of those unknowns. So I have 7x and 2x. 2x is the smallest, so that's the one that I'm going to eliminate from both sides. So at the moment it's positive 2x because there's no sign in front of it. The opposite of positive 2x would be negative 2x. So I'm going to subtract 2x from both sides. When I subtract 2x from the right hand side, 7x subtract 2x is 5x, and then I've still got the subtract 5 there. When I subtract 2x from the right hand side, that eliminates the 2x and just leaves me with that positive 3. Now, because I'm solving, I'm aiming to get it in terms of x equals. So the next thing I'm going to eliminate is the negative 5. So instead of subtracting 5, I'm going to add 5 because we work with inverse operations. When I add 5 to the left-hand side, that eliminates the negative 5 and leaves me with 5x. And then when I add 5 to the right-hand side, that goes from 3 to 8 because 3 plus 5 is 8. The last step is going to be to divide by 5 because currently it's 5 times x and the opposite of multiplying is to divide. And when I divide by 5 on the right hand side, I have 8 over 5. You can leave it as a fraction if you want to, or you can convert it to a decimal if you know what that decimal is. You also have a calculator, so you could put the fraction in and get the calculator to tell you what it is. Either of those answers is going to get you full marks. Part B. Rosa is buying bananas and apples. She buys X bananas that cost 30p each. She buys 2 more apples than the number of bananas. Apples cost 25p each. She pays £5.45 in total. Use an algebraic method to find the number of bananas Rosa buys. Okay, so she buys X bananas at 30p each. So the cost of her bananas in total would be 30x. She buys 2 more apples than the number of bananas she buys. So we could represent that as the number of bananas plus 2. And her apples cost 25p each. So the total cost for apples would be 25 times the x plus 2. So 25 times the number of apples. She pays £5.45 in total. So what we're going to do is if we add the total of bananas and the total of apples, it should cost £5.45. Now we're dealing with pence here, so I'm going to ignore that decimal point and deal with pence in terms of the pounds. So now we've formed an algebraic expression. 30x add 25 multiplied by this bracket is equal to 545. Remember, we're dealing with pence right now. So I'm going to expand that bracket. So 30x add 25x plus 50 equals 545. 30x plus 25x is 55x. And now we've got an equation to solve like the ones we were solving up here, look. So I'm going to subtract 50 because it's the inverse of adding 50. And then I'm going to divide by 55 because it's the inverse of multiplying by 55. So x equals 9. Okay, x is the number of bananas, so that's our answer. Part C, factorise x squared, add 5x, add 4. So this is a quadratic equation that's got a squared term and a number term, so we're going to need 2 brackets. Each brackets will have an x in because x multiplied by x gives us x squared. Now we need 2 numbers that multiply to give us 4, but add to give us 5. So we could have 1 times 4 or 2 times 2. 2 plus 2 is 4, so it can't be that pair. 1 plus 4 is 5, so it must be 1 and 4, and they're both positive. So we factorise that expression into 2 brackets. Question 22. So we've got a diagram of an aircraft descending towards a runway, and they formed a right angle triangle for us. The diagram's not drawn to scale, so we can't measure anything from the diagram. So an aircraft is making its final approach, ready to land. The aircraft is flying at 3 degrees to the horizontal, so we've got those 3 degrees to the horizontal here, and it's 2.5 kilometres horizontally from the start of the runway. So we have 3 degrees from the horizontal here and 2.5 kilometres from the runway here. So that's the base of the triangle, and that's that angle on the outside that's made between the triangle and that horizontal. Calculate the vertical height of the aircraft above the horizontal ground. So the vertical height above the horizontal ground is this height. This is the horizontal ground, and that's the aircraft there. You must show all you're working out. Okay, so we have a right angled triangle. We're trying to find a length. So it's either going to be Pythagoras or trigonometry. Now, if it's Pythagoras, we need to know 2 of the sides of that right angled triangle. We don't know anything about this side, so it's going to be trigonometry. Now, for trigonometry, to find a missing side, we need a side and an angle. So we need to find this angle or this one. Well, I'm going to find this angle because they've told us that the angle with the aircraft and the horizontal is 3 degrees. This is a right angle, so 90 subtract 3 tells us that this angle here is 87 degrees. So we have an 87 degree angle and a 2.5 kilometre length. So let's label our triangle. So this is the opposite, this is the hypotenuse, so the H must be the adjacent. So we're looking for the adjacent and we've got the opposite. So it's O and A. So if you remember SOHCAHTOA for trigonometry, we're dealing with the tan ratio. It's the only ratio that deals with the opposite and the adjacent. Opposite, adjacent. So tan of our angle, we've worked that out to be 87, is equal to our opposite over our adjacent. Let's fill in what else we know. The opposite is 2.5 and the adjacent is the height that we're looking for. So now we know we're looking for the adjacent. So if we cover this up, we're doing the opposite divided by tan 87. That's what this formula triangle helps us with. So we're doing H is equal to the opposite divided by tan of 87. And it's really important that you write it that way in your calculator. Ooh, and then close your bracket at the end. So the opposite side comes before the tan. And then when I press that, we get 0.13101944482. This is in kilometres. Okay, so you can say that it's 0.13 kilometres from the ground. Doesn't ask you to convert it to metres or anything like that, so this would be absolutely fine. It's 0.13 kilometres height from the horizontal ground. 23. Heath has £3,000 to invest for 5 years. No extra money will be paid in or withdrawn during these 5 years. He's going to choose which one of these accounts. So the option here is account A, 4% compound interest per year. Interest rates can vary. Account B, guaranteed interest at the end of 5 years of £190 for each £1,000 invested. Part A, which account gives Heath the greater percentage increase in his money at the end of 5 years, and by how much is it greater? You show how you decide. So let's work out how much interest he's going to earn and what his account will look like at the end of 5 years with each of these two options. So account A, 4% compound interest per year. So if he's starting with £3,000, that 4% compound interest, we're going to use a multiplier of 1.04 because it's 4% increase, and that's a 1.04 as a multiplier for 5 years. 3,000 times 1.04 for 5 years. So that's 3,649.96 in pounds. I rounded it to 2 decimal places because it's money. Okay, account B. Guaranteed interest at the end of 5 years of £190 for every £1,000 invested. So 3,000 divided by 1,000 is 3. So you'll get 3 lots of 190 at the end of 5 years, which is £570 interest. Okay? So that would be 3,000 plus 570 at the end of the 5 years. So we want to see the greater percentage increase. So percentage increase, we're going to do the difference, which is the interest earned, divided by the original times by 100. So the difference, divided by the original. So this is a 21.67%, and then the difference here is the interest. %. So account A gives the greater percentage increase, and by how much is it greater? Well, 21.67 take away 19, it's greater by 2.67%. The assumption that we've made here is that the interest rates in account A don't vary, because it mentions that there. Account A interest rates do not vary, because it says here they can vary. So if it did change within the 5 years, that would obviously change this value. Part B, comment on the effect that your assumption in part A has had on your decision. Okay, so the effect it's had on our decision is that as long as it stays the same, we're correct. So if it's consistent, we're correct, but it could be higher or lower depending on what happens.